Assalamualaikum and good morning everyone. Today we are going to present a project that involves controlling a 7-segment display using a STM32F4 microcontroller. We will control what number or characters are displayed based on the external switch presses. Let's go through the code and see how it works. What does the code do? The program controls a 7-segment display connected to GPIO pins of the STM32F4 microcontroller. An external switch is used to cycle through a set of numbers and characters on the display. The code can display numbers like 1, 3, 5, 7, and 9, also characters like capital A, capital E, small b, capital S, and capital U in a repeating sequence. First, we need to enable the clocks for GPIOB and GPIOC to make sure we can use the pins. Based on the coding at line 8 and 9, we enable the clock for GPIOB and GPIOC, which are the ports where the button and 7-segment display are connected. Next, we configure GPIO pins for output to control the 7-segment display and input to read the button press. Coding at line 12 and 13 is the output, which is the 7-segment display, while line 16 is the input, which is the external switch. This set up the pins so that we can turn off or on specific segment of the 7-segment display and read the button press to change what is displayed. INT count at line 18 on the coding is used to keep track of the current state or position in the sequence of numbers or characters that are displayed on the 7-segment display. INT count blinking equal to 0 at line 19 controls whether the LEDs on the 7-segment display should be blinking or showing a static value. INT count characters equal to 0 at line 20 is used to control the sequence of the characters A, E, B, S, U that are displayed on the 7-segment display. In short, these variables help manage the flow of the program, keeping track of the current state and controlling whether numbers or characters are shown in the display.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izam bin Muhammad Ramzi. I'm an electrical engineering student semester 3. So basically, I'll start explaining my coding starting from line 22 to 39. Okay, so basically this code checks if a button is pressed, then it will display the number, odd number, starting from 1, 3, 5, 7, and 9 in a sequence. And then we have a button press checks. First, it checks if the button PB5 is pressed using GPIOB IDR. So basically, if it pressed, it sets a flag called count blinking and adds a short delay to the bounce. Okay, and then when the flag is active, the switch statement runs. Each case outputs a different hexadecimal value to GPIOC ODR, which displays the sequence. Okay, so for case 0, it will display number 1, and case 1 will display number 3, case 2 will display number 5, case 3 will display number 7, and then for the last case, which is case 4, will display the number 9 and reset the flag. Okay, and then we also have a timing control. So we have a delay of 400 milliseconds is added between the outputs for visibility, and then we have a counter reset. So the counter increases and resets after 5 using count plus 1 mode 5, so the sequence repeats. Okay, and then for any case of occurrence of errors, we have a default case to clear the display to 0 times 00.
For the lines 48 to 56, the code uses a switch statement to cycle through specific values corresponding to characters capital letter A, E, small letter B, capital letter S, U, and write them to GPIOC ODR. GPIOC ODR is the output data register that controls the state of the GPIO pins. Each hexadecimal value sets specific pins high or low to represent a letter or state. Case 0 outputs 0 times EE represents character capital letter A. Case 1 outputs 0 times F2 represents character capital letter E. Case 2 outputs 0 times F8 represents character small letter b. Case 3 outputs 0 times DA represents character capital letter S. Case 4 outputs 0 times 7C represents character capital letter U. The counter resets to 0 after this. Default outputs 0 times 00 error state if something unexpected happens. After displaying each value, the program waits 400 milliseconds using the delay ms bracket function. The counter bracket count is incremented and loops back to 0 after 5 states. For lines 62 to 71, the delay ms bracket INTN function creates a software delay for n milliseconds. It uses two nested loops. The outer loops runs n times. The inner loop runs approximately 7,200 iterations per millisecond. This value is calibrated based on your microcontroller clock speed. The volatile keyword for J prevents the compiler from optimizing out the delay loop.
When the switch is pressed for the first time, the 7 segments will display the number 1, then 3, then 5, then 7, and 9. And then it stops. And then for the second press, it will display the capital letter A, capital letter E, small letter B, capital letter S, and then capital letter U. That's all.